Welcome to Ask and Learn.
So in this case, we have a volcano which is spewing rocks vertically upwards from the mountain, and the rocks are like going upwards and rises vertically upwards a distance of 320 meters. And we need to find out what is the velocity when it left the volcano, which means at this location. So again, we have level 1 and level 2, and we can equate the energies at these two locations. E1 is equals to E2 because there are only conservative forces acting on the system. And we have y1 is equals to 0 and y2 is equals to 320 meters. If we equate the energies at these two locations, you will get half mv1 squared is equals to mg y2, because at this location there is no GPE and at this location there is no kinetic energy. If you solve that, you will get v1 squared is equals to 2g y2. v1 is equals to approximately 79 meters per second. The volcano spews out the rock so that it achieves a height of 320 meters. For the B part, we need to calculate the power output. And the power output is the energy transferred to the launch rocks per unit time, basically. So power is equals to the energy transferred per unit time. So the launching of energy of a single rock, for one rock, the energy is half mv1 squared. So for 1,000 rocks, it's going to be 1,000 times half mv1 squared. And if you divide this by 1 minute, you should get the power. So therefore, the answer is 1,000 times half times 450 times 79.2 divided by 60 seconds. That should give you 2.4 times 10 to the power of 7 watts. So that's the power output.